As a kid, my favorite class field trip was to the Science Museum in downtown Seattle, and it always ended at the planetarium. The whole class would lay across a floor mat and try to name as many planets as we could. We'd point out the Big Dipper and the North Star as the night sky shifted along the ceiling. Even today, when visiting a new city, I drop into the local planetarium for the excitement and thrill of revisiting the wonders of our solar system. Will there still be 9 planets like I learned when I was young? How many more moons have we found since last I checked? There's always something new to wonder at when it comes to outer space. And while it might be a while before school children are asked to count the over 5,000 known exoplanets that exist today, we do know the world of space research is about to open up drastically. I'm Sherelle Dorsey, and this is TED Tech. Today, astrophysicist, TED Fellow, and planet hunter Jessie Christiansen takes to the stage to share her discovery of a new generation of planets and what it means for how we think about our world.
I am a planet hunter and keeper of the keys at NASA's Exoplanet Archive. In March 2022, we reached a major milestone in space exploration: 5,000 known exoplanets. For thousands of years, we've wondered about planets outside of our solar system, now called exoplanets. But our technology only recently caught up with our imaginations. And yes, 5,000 planets is incredible. What's even more incredible is how space research will change as a result. When I started grad school, there were about 100 known exoplanets, all radically different from the Earth and from each other. I was determined to find more. I spent 4 years looking at nearly 87,000 stars, one by one. Now, you might have this romantic idea that I was gazing intently through a telescope, pondering some gorgeous view of the universe. I was not. I was looking at data, measuring the brightness of each star over time. If the brightness dipped, just briefly, just a little bit, it could be because a planet had orbited in front of that star, blocking some of the light from reaching my telescope. So, I spent 4 years looking for decimal level changes in these data, and after 4 years, I'd found nothing. 0 exoplanets. Thankfully, they still gave me the PhD, I think for effort. Then I moved to Harvard, where I worked on my first NASA mission called Epoxy. I still didn't find any exoplanets. Then in March 2010, I joined the Kepler mission, NASA's grand experiment with putting one of our planet hunting instruments into space. Monday was my first day on the base in Silicon Valley. It was mostly spent in HR. Tuesday, I sat down and looked at the data for the first time, and I found my first exoplanet. A few minutes later, I found another one. There's a saying that we're the generation that was born too late to explore Earth and too soon to explore space. That's not true anymore. That day, and every day since, I've gotten to explore space. Kepler made it possible for us to measure stellar brightness much more precisely than we had before, and eventually I helped find thousands of exoplanets. And we've really only searched our local corner of the galaxy to find those planets. That means there's likely tens of billions of planets just in our Milky Way. Now, with so much data, we can start sorting and grouping and categorizing these planets to find trends. Think of it this way. If you wanted to learn about dogs, and you had 5 dogs in your study, well, you'd learn a lot about those 5 dogs, that they're all good dogs, but maybe not about dogs in general. If you had 5,000 dogs in your study, then you'd start to see that there were German Shepherds and Dobermans and Beagles, and that these different breeds have different features. With demographic level data on exoplanets, we can start asking some of these big questions for the first time. Like, of those thousands and billions of planets in our galaxy, how many are like the Earth? Or like Jupiter? How many planets does a typical star have? Can a planet orbit more than one star? Yes. Can a planet exist without any star at all? Also yes. One surprising result from the study of planet populations is that the most common kind of planet in our galaxy might be one we don't have in our solar system, a super Earth, up to twice as big and 10 times as heavy as our Earth. We've found evaporating planets, disintegrating planets, planets clustered together in a clockwork dance, ultra-puffy planets, ultra-dense planets. It's truly a wild and wonderful menagerie that I get to corral at the NASA Exoplanet Archive. But it gets even more interesting than that. With so much data, we might finally be able to figure out how planets are made. We see baby stars being born in stellar nurseries, surrounded by dust and gas. And we see older stars surrounded by completed planetary systems. But we still don't really know what happens in between. With more data, we might find planets at some middle stage or many middle stages, and from there, be able to map out a timeline of planetary development. What triggers these diffuse clouds of dust and gas to collapse and transform? And how does the chaos and turmoil of dust become pebbles, and pebbles become boulders, and boulders become planetesimals, and from there, after an intense series of bombardments, eventually settle into an ordered series of planets? How often is one of those planets solid and warm, with a water ocean lapping a sandy shore? Where do we come from, and how did we get here? The more we learn about exoplanets, the easier it is to target the ones we want. So far, we haven't found any planets that are like the Earth, but I hope we will. NASA just spent the last few years studying the idea of a very large telescope in space with next-generation technology that would allow us to take an image, an actual photograph of a planet like the Earth. With that photo, we could search for biomarkers, signatures of life. I'll probably spend the rest of my career working on that mission. I hope I get to take that photo. Thank you.
All right, that's our show. Thanks for listening. TED Tech is part of the TED Audio Collective. This episode was produced by Isabel Carter, who also wrote it with me, Sherelle Dorsey. Our editor is Jimmy Gutierrez, and the show is fact-checked by Julia Dickerson. Special thanks to Farah DeGrunge for her support as a project manager. I'm Sherelle Dorsey. Let's keep digging into the future. Join me next week for more.